All right, so for our warm up today, we're reviewing our normal curve, our standard normal, and our regular normal probabilities. So let's look at a couple examples together as we do this warm up. So for each of the problems, label the standard normal distribution with the given z-score, shade in the appropriate area, then determine the probability. So remember, in a standard normal curve, the mean is always 0 and the standard deviation is always 1. So the middle of our normal curve is always 0, and then our standard deviations go out by 1. So if I want to know all the values greater than negative 2.13, yeah, so negative 2 is over here, so negative 2.13 would be right about there. And I want everything greater than that. So I want to know the area under the curve of this shaded region. I'm looking for the probability of getting a number greater than negative 2.13. So because I want the area underneath the curve, we're going to use our normal CDF. So remember, when we plug that into our calculator, it wants the lower bound. So where does it start on the left, which is our negative 2.13. Then it wants our upper bound. Since we're looking for everything greater than, we're going to go all the way to the edge of this graph. So remember that we type in as 1e to the 99 as our upper bound. And then again, our mean is 0 and our standard deviation is 1. So we'll type that into our calculator. If we hit second, then vars, go to our normal CDF. Our lower bound is negative 2.13. Our upper bound is 1e to the 99. Our mean is 0. Our standard deviation is 1. And that will tell us that the area underneath that curve, the probability there is 0.9834. So we're going to do the same thing for number 2. So again, our mean is 0. Our standard deviations are 1. So then I want to be between negative 0.59, which would be between 0 and negative 1, and 1.98. So I want to know the area of this region here. So because, again, we're looking for the area underneath the curve, we're going to do our normal CDF. So our lower bound, right, the lowest part of our shaded region is this line. So that's our negative 0.59. Our upper bound is over here at this line, 1.98. Our mean is 0. Our standard deviation is 1. So we'll do our second vars normal CDF again. We're going to negative 0.59. Our upper bound is 1.98. Mean is 0. Standard deviation is 1. And so then when we solve for that area, we get 0.698, and we'll round that to 6 as our area or our probability. So that's our standard normal curve. That's when our mean is always 0, our standard deviation is always 1. But last class we talked about that that's not necessarily the only option that we have. We can solve this with any mean and standard deviation that we want. So these 5 questions are all along the topic of the test scores on the last exam were normally distributed with a mean of 72 and a standard deviation of 5. So in this case, yes, our mean is 72 and our standard deviation is 5. So we would count out 5 this way. And then this would be 67, 62, 57. So our mean is 72, so that goes in the middle, and then I just counted up by 5 and down by 5 to get these values. So then I want to know what percent of scores are below 80%. So, right, 80 is going to be roughly here. And it doesn't have to be a perfect guess of where 80 is, but we know that 80 is to the left of 72, or to the right of 72, sorry. And then I want everything below that, so I want this shaded region going this way. So again, we're still looking for area underneath the curve. So we're still Going to use our normal CDF. Now this time I'm shading all the way to the left. So instead of positive 1e to the 99, I use negative 1e to the 99. So my lower bound is negative 1e to the 99. I'm going all the way to this upper bound, which was 80. And then my mean is 72, and my standard deviation is 5. So I'm going to go second vars, normal CDF. I'm going to be at negative 1e to the 99. I'm going, my upper bound is 80. Oops, I messed that up. Upper bound is 80. My mean is 72. And my standard deviation is 5. So I get that my area is 0.9452. All right, so we'll do the same thing for number 4. What percent of scores are above? And I'm going to leave this as a probability. If you want to turn it into a percent, we just move it 2 decimal places. So we get 94%, 0.52%. But I'm okay in this case of leaving it just as a decimal. So what percent of scores are above 60%? So again, we know our mean is 72. So 72 is here. And we can count this way if we want, just to kind of get a rough idea of where 60 is. But again, as long as you know it's to the left of 72, kind of a ways over, this is just an estimation of the area. It's not kind of an exact spot. So I'm going to go, all the scores above 60 are going to be all of these going this way. So again, this is my normal CDF because I'm trying to find the area underneath the curve. My lower bound, I'm starting at 60. I'm going all the way to the end of the graph on the right side. So remember, this is my positive 1e to the 99. And then my mean is 72, and my standard deviation is 5. So I'll again type that into my calculator. Second vars, go to normal CDF. My lower bound is 60. My upper bound is 1e to the 99. Oops, that's not right. 1e to the 99. My mean is 72. My standard deviation is 5. So then I end up with 0.9918, which if you want to turn into a percent would be 99.18%. Okay. So this is what we talked about last class and where it got a little bit different. We actually know the area underneath the curve that we're looking for, but we need to know what that cutoff X value is. So the first question asks, what score would put you in the top 10% of the class? So being the top means you're at the right edge of the curve. So the top 10% is going to be somewhere over here. And so that means the area of this curve is 0.1. So I know the area of this curve, but I need to know what X value would be like the cutoff score for that top 10%. So there's 2 ways that you can do this. Depending on your calculator is going to kind of depend on how you do this. If you have a newer calculator, if I go to second vars, I'm going to number 3, which is my NV norm. And it's going to ask you for area, which is 0.1. And then our mean is 72. And our standard deviation is 5. And this is where it differs. This calculator asks me where am I shading in this region? Am I shading on the left, the center, or the right? In this case, right, I'm shading on the right side of my graph. So I would select right. And then it can find the X value for me. So it says that to be in the top 10%, this cutoff score would be 78.41. So everything above 78.41 would be in the top 10%. Now, if your calculator does not let you pick right, left, or center, your calculator is always going from the left. It's not a big deal. It's just going to change how you type it in. So if I went 10% this way to get to that X value, then I have to go 90% from the left to get to this X value. Remember, I already know the shaded region. I'm looking for this location of X here. So it doesn't matter which end I come from, it's going to give me the same value. So if your calculator does not let you pick, again, it's always then assuming that it's coming from the left. So the only difference is you would have to use 0.9 to represent coming 0.9 from this direction. And then 72 and 5, and then you're coming from the left. Your calculator won't even say left, it's always assuming left. But if we do this and we hit paste, I did something wrong. I forgot to change it to 0.9. 0.9 from the left, paste. Now I have the same value that I had up here, right? Because it's just getting me to this location of this z-score here. So my answer is 78.41. All right, so the next one asks what score would be the cutoff for the 60th percentile. So this is asking if I want to be on the 60th percentile, I want to be 60% over this way. So if this is 50, 60 would be about right here, right? So the 60th percentile is this, right? Working up to this area right here. Puts you in the 60th percentile, this X value. So I know the area over here is 0.6. So now it doesn't matter what kind of calculator you have because we're coming from the left anyway. So again, my area that I know that I've used 0.6 of the area, and I want to find out what value is the marker for our 60th percentile. So I'm going to do my NV norm. My area is 0.6. My mean is 72. My standard deviation is 5. And then I'm coming from the left, which if your calculator doesn't let you pick, it's automatically assuming the left anyway. So my area is 0.6, mean is 72, standard deviation is 5. And then I'm coming from the left side. So that score that puts me in the 60th percentile would be a 73.27. If you wanted, you could go 40% from the right and you would get the same answer. But since all of our calculators kind of default to the left, I would just do it from the left. Okay. It says, what scores would you need to make up the middle 50%? So I'm actually looking here, right? I'm looking for what scores are here and here that make up, right? If you're between these two scores, you're in the middle 50% of everybody. So my area in here is 0.5. So now, if your calculator is newer, I can do my NV norm of 0.5, mean of 72, standard deviation of 5, and pick center. So if I do that, area is 0.5, mean is 72, but now I want to know the center. It's actually going to tell us the two values that make up the center. So 68.63 and 75.37. Those are those two values. So if you have a score between these two, you would make up the middle 50%. Now, if your calculator doesn't let you pick center, remember it's always assuming that it's coming from the left. You can still do this. You just have to do it in 2 steps. So first, if I want to get to this value here, if this is the middle 50%, then this would be, to get to here would be 0.25, correct? So then that means I'm going to do NV norm from 0.25, mean of 72, standard deviation of 5. So when I do that, I'm coming 25% this way, or 0.25. All of this stays the same. It's coming from the left because that's all your calculator does. And there it gives me that value that we already found there. That's 68.3. So then to get to this value over here, right, I have 25% and 50%. So now I'm going to come 75% from the left. Mean of 72, standard deviation of 5. So I can really just copy this and turn this to 0.75. And I get that same value that we found here from the center button. So this way, It's just when we're going from the left both times, you have to go from the left on both of these to get those two values. Okay, so the back is exactly the same as the front, just a different situation. So go ahead and try the back, and then you can check your answers with the ones that are on Schoology.